Aaron's going to talk us through microservices.
All right, thanks, Krista. So today we'll just give a kind of a brief overview of what microservice architecture is and maybe how to think about it. This is definitely meant to be a little bit more of a primer on how to move the needle within your organization to get away from some of these monolithic applications. So you can see the name here of the talk is moving past monolithic applications with microservice architecture. So brief agenda, I'm just going to lay out a problem scenario, a potential solution, that being microservices architecture. Then I'll jump into kind of a real world example that BP3 engages with. And then I'll just briefly summarize and hand it back to Krista and our MC, David Bailey. All right, so let's imagine that you have a business application that needs to be brought into the modern computing world. Demand for the system is outpacing throughput, right? So kind of as Reiner alluded to, you have people working for the system. It takes real, system experts to keep the system moving and production in line. The costs are increasing, whether that's through development, maintenance, or operation. From an accounting standpoint, things year over year just keep piling up. And meanwhile, throughput is also decreasing. So maybe it's time to look at a better way to achieve that business problem. Now, the result of this monolithic application is probably born out of some of the fact that 10, 15, 20 years ago, hardware and operating systems were chosen for the 80% of core functionality for your business application. But there's still that 20% of your business application that wasn't really thought of or really addressed when choosing the hardware and the operating system and all the middleware components that are required for your business application. And those kind of end up being the dark corners that I think we are all familiar with, where it's just a sliver of the application functionality, but from a development and maintenance standpoint, it really consumes an outsized portion of time and effort. And so I named this slide "The Solution," but really it's just a solution, because I think we all know that there's many different ways to solve a problem. But if we bring ourselves forward into the modern computing era, we now have cloud computing, and really we can think of this not just as the place where our photos get stored, so we never lose them, but really it's infinite computing power. And infinite computation means that we can have unlimited machines, and specifically virtual machines. So this is really the concept that allows for microservice architecture, is cloud computing, because ultimately microservice architecture is loosely coupled services that are built on independent virtual machines that are networked together. So this allows you, so by using microservice architecture, this is going to allow you to build an application that can evolve over time. And maybe you have, one piece of an application that does one piece of work. And as that technology evolves and goes through the normal life cycle, maybe that particular technology that was chosen 10 years ago isn't so applicable today, and there's a better solution. And so the idea is, in a microservice architecture environment, you'd be able to easily swap out that piece of functionality as it kind of operates as a black box. So moving with that idea, there to me is a pretty clear analogy when it comes to microservices, and that is that microservice architecture does for software building what Eli Whitney's interchangeable parts did for manufacturing, right? In the case of Eli Whitney's interchangeable parts, there's physical products that are being built by predetermined identical hardware components, and focusing on the practical application of that product. So you can see here I have a little everyone's favorite IKEA diagram, and IKEA is able to maintain thousands of products using just a few dozen pieces of hardware to hold it all together. And that's not really that exciting anymore. But I think if we move forward into the cloud computing world, we can take this analogy just a step further and say, well, now we can build software products using predetermined identical middleware components and focus on the digital application. So if I blow out my slide here over on the or picture on the right, we can imagine some cloud environment, and let's say we're building a customer service application. We can segment our application into 3 different components, which we'll think of as microservices. So you'll have a database that will keep the customer records. You'll have a service that will manage the customer interaction. So let's say I'm a customer service agent, and I want to see everything that's happened, or everything that the customer has been involved in from an interaction standpoint. They called 2 weeks ago about problem X. They called 4 weeks ago about problem Y. You would have a microservice that would allow you to basically pull all the interactions that happen based on the particular customer that's calling in. And then likewise, you would also have a microservice for customer requests. So they're calling today. We want to see that they had an interaction both 2 weeks ago and 4 weeks ago, but now we need to create another request for them. And so you can kind of see I've very simplistically drawn out what these services might look like from a architecture standpoint. And my slide got a little screwed up here, but there's supposed to be a legend at the top left, and the orange lines represent interchangeable middleware. And meanwhile, the black lines represent the custom code that's the actual business application that your company would maintain. So things from the OS all the way down to the actual databases can all be specified in a repeatable fashion, and then that kind of just leaves your application code that needs to be maintained by developers. So you might hear this term, infrastructure as code, and this gets to this reusable hardware / middleware component of cloud computing, where we can have human readable files that basically define the runtime environment. So really, this isn't all that interesting, but what this file really represents is a runtime environment. And because it's written like software, that means that we can maintain it like software. And so that means it can follow all of the same development processes that make really good development teams run efficiently. We can do the same thing for provisioning hardware and middleware and different components, so that a mature organization, a development group should be able to quickly spin up an environment to try to tackle a business problem without having to go through the processes before provisioning hardware and installing operating systems and getting the environment to a state such that you can actually start thinking about how are you going to actually solve the business problem a little bit differently by working with this concept of infrastructure as code, right? Having environments that are already predefined with static files that are all maintained using a development, a standard development process. That gives a lot stricter control over what the environments can and will look like, but also gives the great benefit of being able to get stuff done a lot faster.
So, Aaron, you make a really interesting point there. It's like you can, as a business person, when I come to you with a problem, instead of you having to think about what's the right infrastructure, what's the right, um, how am I going to spin this up? How many different people do I have to contact in my ops center? You already have it ready to go. Press a button, and then you can get to solving the business problems without really thinking about that up front and maybe coming to that later, uh, making you move a lot faster. Is that kind of what you're saying?
Yeah, exactly. So, you say you come to me on Monday and say, hey, I need I need a level of estimate on, what it's going to cost to have this feature. We're going to need a new database to track this. In the old world, it's okay, give me 3 months and let me get an environment that IT approves of. In this type of environment, it's like, okay, I'll let you know by Friday what I think is possible. So I think it's really about achieving, um, scale much faster and being able to get to the application code that matters. Whereas, the stuff that basically sets up the application environment, all that is abstracted away.
Yeah,
I've
being
also seen
someone who
this sort
does
of,
come to you on a Monday and says, I need it by Friday, I really appreciate that.
I've also seen this sort of architecture really improving the ability to troubleshoot something in the applications as well, right? So the developers can spin up something that resembles production in their local environment and do troubleshooting and really see what's happening there. So it's a great progress in software engineering.
So now we'll look at a real world example that BP3 works within. So Keller Williams, the world's largest real estate brokerage, engages BP3 to build their Smart Plans microservice, which is part of a larger whole that is their web-based real estate CRM platform. And Smart Plans are simply user configurable workflows. So the user being a real estate agent, and much of this was covered yesterday, so I'll try not to repeat too much. But effectively, these workflows are basically, packaged touch points for an agent to talk to a contact, whether it's on the buy side or the sell side, having these managed workflows to send text messages, send emails, just engage with contacts on a regular basis, which is a huge part of the real estate sales world. Being able to manage how they interact with their contacts is really big for their agents. So you can see through this screenshot, this is a pretty modern looking web app, and on the left here we have a bunch of different modules, and the one that we're looking at is the Smart Plans module, which effectively is a service that is probably composed of a bunch of microservices, is probably the best way to think about it. Let's see, what's this next slide, right? So these configurable workflows ultimately translate into command workflows on the back end. And that is what Keller Williams and BP3 work together to develop and maintain. There's, again, some different pieces that connect the actual CRM app to the command workflow engine. But at a high level, one smart plan equals one command workflow instance. And again, there's a bunch of supporting pieces that all make that work, and that's kind of loosely drawn out here. So we have the user interface. A user can create a smart plan to work with their contact in a managed way, and then there's a messaging bus or a data feed that allows all the different microservices within Keller Williams, not just smart plans, to listen for different events that happen within the web-based CRM. And so in the case of our smart plan service, we have a controller service that's just monitoring that messaging bus. And when something happens that we care about, we tell the command process engine that we need to start a smart plan, and then that creates some entries into the database. And again, this is a pretty simplistic view, but at a high level, I think that suffices kind of the basic, at least, components of how a smart plan is ultimately operating. But again, to the user, it just looks like a web app, right? The user has no idea that, it takes 14 REST calls in order to get a smart plan running. It just works. And let's see, what's the next slide? So in the future, if, let's say, communda were to fork their code base and had a way better process engine, 10 years from now, let's just pretend, changing out the communda process engine, in theory, should really be like a black box. We have inputs that go into the communda process engine, and we have things that come out of it. And what happens in between, we don't really always care about, right? So in that way, that's kind of how we can think about microservices as interchangeable components within the broader context of software development. Now, I've glossed over a lot there, but we'll just go with it. And so this is a screenshot here of the Google Cloud Platform environment within Keller. Not a ton interesting here, other than I just kind of wanted to show that, back to this idea of infinite computing, you can see that for their one cluster that runs all 200 and some microservices within their entire company's infrastructure, there's 136 virtual CPUs and over 1,000 gigabytes of memory, right? So that's a very large computer. So having that infinite computing power really opens the door for microservices. I don't think it would be very advantageous to try to create a microservice architecture using all on-prem hardware and software. Okay, so we'll just round out with the benefits of microservice architecture. This allows them to isolate code changes and deployments. Development teams are distributed across services. So as mentioned, the Smart Plan service is both BP3 and Keller Williams. But likewise, there's a whole team dedicated to the UI. There's a whole team dedicated to the contact service. And we're able to operate in isolation pretty effectively. I mean, it's not like, we the Smart Plans team don't necessarily contact the contacts service. However, there's a lot of overhead that happens above us to make sure that all the teams are working in order. So it's not like we're isolated and that's all just abstracted away. There's definitely a lot of good work that's done to make everything stay in sync. But at least from a development standpoint, we're able to focus on what our strengths are. And we integrate using different web protocols, and we're able to consume and invoke other services. And then that allows us to delegate our operating system and our environment and all of our middleware components for whatever's best suited for our services existence and purpose in life, right? So in the case of Smart Plans, we use communda and everything that communda requires to create our service. But if you wanted to do an IBM BPM microservice, that in theory would be possible as well. So having enterprise level opinions of what these runtime environments should be, as well as the rapid deployment, makes provisioning the hardware and just the whole ramp up time to development much, much faster. So lastly, think about microservice architecture if you're in a monolithic application environment and you know that you've got to basically boil the ocean to get off of this application. By using microservices, you can kind of think about, carving off different chunks of functionality and placing those into their own microservice. And over time, it will develop this paradigm of infrastructure as code. And that kind of gives rise to this idea that your IT operation can be a series of interchangeable parts, each service being its own black box that can be upgraded as technologies evolve, and then distribute that development across functional areas of expertise. So just like Keller Williams, you can hire BP3 to manage and develop your process automation bits, and hire out the work for other critical components with very specialized vendors who are experts in a particular field.